Okay. Today I'm going to focus on geometry. Okay. Well, geometry will focus on triangles, rectangles. You know, there are still some material we need to go over. Okay. So the first question is giving us three numbers, whether or not they can become the side lengths of a triangle. How to determine that? Okay. Given three numbers A, B, C, okay, and how to determine whether they are the sides of three triangles, okay. So that's a question, okay? So not all the numbers, three numbers, you can form a triangle, okay? The reason is, see, look at this. If suppose this is a A, right? Now, if B plus C is short than B plus C is smaller than A, then you cannot form a triangle because B plus C, if you go from one point to another point, right? The strict line is always have the shortest length. So if it goes through another point, then it's longer. So that means B plus C, it is going to be, sorry, it's going to be, so where's my file? Yeah. I'm trying to find my file. I accidentally touched. Yes, here it is, okay? So, so B plus C should be greater than A, right? But same reason, A plus C should be greater than B, okay? And then A plus B should be greater than C. So as long as those three inequalities hold, then that becomes the three sides of a triangle, okay? So given three numbers and you know how to determine whether they are the sides of a triangle, okay? Yeah. So the special case is for an isosceles triangle, right? For an isosceles triangle, you have a 1B and 2A, right? So you have two numbers, A and B. So whether they form a triangle, it's really depend, you know, A plus A, right? 2A should be greater than B. This is only inequality you needed to check. Why? Because A plus B is always greater than A, right? So you don't worry about, you know, the sum of the two sides should be greater than the other side, right? A plus B, you know, is greater than A always. So it's automatically satisfied. So this is the only inequality you needed to check. Okay, this is only inequality needed to check. Okay. Okay. So here's a question. Okay. Okay. So we have a triangle. So this, yeah, let me give you the problem. All right. So you're given the triangle A and B, and where A and B are integers, okay? Then the parameter is fixed. It's going to be 16, okay? So find the triangle with maximum area. So it was the largest possible area, okay? So they are not unique. You have several triangles satisfy this condition. First of all, A and B must be integers, okay? Now, you don't have an infinite many triangle. If you do not assume A and B are integers, then you have infinite many triangles there. It's much harder to do that, and you have to study calculus in order to solve this problem. But since A and B are integers, so then you only have finite many such triangles there, so you can determine the largest possible area. Okay, so let's do it. Okay, so parameter equals 16, so that means 2a plus b equals 16. It's a fixed. Okay, then also have to make sure 2a plus b, 2a is greater than b. Okay, so there's inequality, there's equality here, inequality. So let's find all the possible solutions. Okay, so b is less than 2a. So what is the possible value for b? You know, first of all, b is going to be 16 minus 2a, which is 2, 8 minus a, right? So from here, you can see that a cannot be too large, otherwise b is negative, right? From here, a should be equal to 1, 2, 3, all the way to 7. Just look at this inequality. But if a is too small, then the inequality does not hold, 2a greater than b, right? A should be too small. So just look at this inequality. Just look at this equality, you get this conclusion. A can be, you have 7 possible solutions, right? But not all of them satisfy 2a greater than b, okay? So you can write down the corresponding solution here, right? B equals, when a equals 1, and that's 14. When a equals 2, 6 times 12, and 10, right? And so when a equals, this is 2, the smallest number. Now, which one gives you the solution 2a greater than b? Okay, think about 2a greater than b, right? Which one? Well, it's hard to check, right, from here. So they're somewhere in the middle, right? When a equals 3, when a equals 4, yeah, this will be 8, right? And when a equals 4, 8 minus 4 is 4, it's 8, right? Then 2a is 8, b is 8. So this still equal. I think a should be equal to 5, 6, 7. Only have 3 solutions, okay? So clearly, yeah, so that 2a is greater than b, okay? So now you have 3 solutions, okay? So the first one, 3 possible triangles, a equals 5, 5, and then, and that's 6, okay? Total will be 16, right? Another one is, it's longer, and 6, 6, okay? Then this will be 4. And the third one is 7, 7. That will be 2, right? So which one has the largest area? I think probably the middle one, and probably the one on the left. Okay? Okay. So let's take a look at, how do you find the area? If you have if you have a isosceles triangle, right? Yeah, you draw the height, find the height maybe, right? So yeah, look at the height. This height, h is going to be square root of 5 square minus half of the 3 square, right? Okay, so that actually is easy to get out. It's a 16, so it's square 4. And this h is going to be 6 square minus 2 square, 36. 36, no, 32. Square 32. I'm not going to multiply, like simplify it at this moment, okay? Yeah, 36 minus 4 is 32. Okay, and this one will be 7 squared minus 1 squared, 48. Okay. Why I don't want to multiply this out? Because I want to compare which one has largest area. So here's base times height. Okay. Times height, height is 4. So this is going to be 6, right? And this one is a base times height. Okay. That's twice of 32. And this one is a base times height. It's square of 48. Okay. Square of 48, and that thing is pretty small number. Because when you move 2 to inside, right? So 32 minus times 4, 128. Okay. And this will be square root of 36. And clearly, the one in the middle is going to be the largest. Has the largest area, right? All right, right. So, you know, if my computation is correct, the one in the middle actually has the largest area, square root 128. You can simplify, but it's easy to just look at the same formula, radical form. Okay, 6 is square root of 36, right? Yeah. You know, we thought maybe the one in the left, on the left has the largest area. Yeah. Any different answers? Yes. Oh, hold on. The one on the left, that was a computation. Yeah, the base is going to be 6. You're right. So this is a 6. Hold on. Let me check. That would be 12. Right? The base is 6. 6 times height divided by 2. So it's 12. Okay? 12 is 144. Got it? Yeah, I think now it's the one on the left-hand side, the one is, has the largest possible area. Okay, there's 3 different. So be careful. Let's look at, yeah. Okay, now everything's correct. Okay. Yes. Right. Yeah. So my question here is, yeah, this is where, how do we find the area for the isosceles triangle, okay? Now, my question is, do you still remember how do we get the area of a circle, okay? Which one gives you the area of a largest circle, okay? So here, among, so here's 5, 5, 6, and 6, 6, 4, and the next one is 7, 7, 2. I have 3 circles inside. Okay. Which circle has the largest area? Largest possible area. Okay. Kevin says the one on the left. Okay.
I agree with Kevin.
Okay. Now,
We know Kevin.
so we just need to know which one has the largest area, largest radius, right? How do we find the radius?
Divide the bottom one.
Okay. We have some good idea here. They all have the same parameter. That's a good part, right? So you have 3 triangles. So the area of the triangle, okay, is going to be area of base times height, right? And half of the base times height, and half of the base times height. Height is the radius, right? So you can, so area of the triangle is going to be the sum of the area of this small 3 triangles. Okay, this is a decomposition. Okay, so let me mark this. We are talking about triangles like that. Okay, we have 3 triangles, but each of the triangles have the same height, which is the radius. Okay, so the parameter here is going to be 16. So that all equals 8. Okay, so which circle has the largest radius? It really depends on the area of the triangle, right? So the area of the triangle on the left-hand side has the largest possible area. So that is why you the radius is going to be the radius is going to be this is the one on the left-hand side has the largest possible radius. Okay, so then the area of the circle, okay, this circle has the largest area among all the 3 circles. Okay, so the answer is this triangle. Okay, this triangle has the largest possible area among the 3. So our next problem is going to be rectangle also. Let me ask you the following question. Now remember, when we're given a rectangle, right, here's A and B, and this is a D, right? According to this is a rectangle. Okay. We know that by the Pythagorean theory, D squared equals A squared plus B squared, right? So as long as you know, then the area is going to be A times B, right? This is the area. Okay, right? And we also have the following identity, okay? A plus B, that's just pure algebraic identity. It's going to be A squared plus B squared plus 2AB, right? And look at this identity, what you can get. Parameter, P is going to be A plus B multiplied by 2, right? So this is a parameter. Okay. So the following identity tells you this will be half of the parameter, right? A plus B. And this will be the square of the diagonal, right? And this will be the area. So there's a relationship among those 3 quantities. So if you know the length of diagonal, and if you know the parameter, you can determine the area. But if you know the area, if you know the parameter, you can determine the length of the diagonal. You don't need to know exactly the, you don't need to know the dimension of the rectangle. So here's a question, okay? The question is, if a rectangle has a parameter of 10 units, okay, and the length of diagonal of the diagonal length of, or length of diagonal, okay? It's going to be 3 units, okay? What is the area? Okay, so if you know 2 of them, you can get the rest of that. Okay, so the parameter. Okay, so you draw the triangle. Suppose you don't know the formula about formula. So here's A and B, right? So 2A plus B is going to be 10. That's a parameter. Okay, we also know the length of the diagonal is going to be 3. Okay, so that means it is going to be, this is a D. Okay, D is going to be square root A square plus B square. So, so from here, right? Now, if you remember the above identity, then P square, half of P square, which is 5 square, equals 3 square plus 2A, right? Okay, you apply above formula to this problem, then 2A equals 5 square minus 3 square equals 4 square, 16, and then area is going to be 8 square units. Okay. Okay. So here's a question. Okay. Here's a rectangle. I'm given, okay, given the information, the diagonal length is going to be, the diagonal length is going to be 3 units, and the width is going to be 1 unit. Okay, what is the area? Okay. So please do this problem.
Square root of 8.
Joshua, what do you got?
Square root of 8.
Square root of 8.
I know I got it wrong.
How do you know you get it wrong? Square.
It's just not simple.
Yeah, you should simplify, right?
Math test today with the simplify side.
Alan says square root 8. Square root 8 should be written as 2 square root 2, okay? Yeah, 8 is 2 times 4. All right, so let's work out, right? According to this is D, right? We know that A is going to be 1. A, we don't know. B is going to be 1, right? And the D is going to be 3. So A, according to the Pythagorean series, D square minus B square, which is 3 square minus 1 square, which is square root 8. Okay. So then area is just 8 times B. It's 1 times square root 8. It's 2 square root 2. Okay. Yeah, 8 should be written as 2 times square root 2. Okay. My next question is, I have a square, Okay, and I have another square that connected like that. Okay, this is another square. This is also a square. Okay, if the area of the smaller square is equal to 3 square units. Okay, what is the area of the largest square? Okay, what is the area of the largest square? Okay, you know you have 2 squares, right? The largest square, the side is the diagonal of the smaller square. Okay, Kevin says 9. Any different answers? Oh, Alan says 18 units, square units. Wow. All right, let's look at, okay, this is A, right? That's A, right? And that is a B. That's a B, right? So A square equals the area of the smaller square, which is 3, right? Then what is B square? B square is A square plus A square by Pythagorean theory. Is twice of A square, which is going to be 2 times 3, that's 6. And that gives area, okay? So this is the answer, okay? The area of the largest square is going to be 6 square units. Got it? By simple relationship A and B. Yes. Okay. Another a little bit tricky problem is, okay, so this is here's a square, okay, so it's a square, okay, and this square has each side 10 feet, okay, 10, okay. What I'm going to do is here's a 1, that's a 1, 1 and a 1. Draw a line. I'm going to, here's the same 1, 1. Okay, and draw another line. I'm going to get rid of this area. So what I'm going to do is the remaining area, become the long. Okay, so it's green. Okay. Right. So now people walk on the diagonal. Suppose you have a square, okay, and the size here is, yeah, this each side is 1, 1. You cut it, right? That's you measure it. 1, 1, 1, 1, 1, and 1. Okay, my question is, what is the total area of the shaded region. Okay. So you have a 4 triangles there. Add them together, the area. Any ideas? You can do it, okay? Your knowledge, you have the knowledge. So the question is whether you have the skill to solve the problem. Okay? You understand problem, right? On each corner, I measure one, and then that's the point, and I draw the line, and then I have this is this is for the walkway, people walking through them, and on the diagonal path. Okay, the other area can plant some flowers, whatever. Okay. So Emma got the first answer. Great. Any different answers? You have, there are a couple ways to solve the problem, right? If you find the area of each triangle, right, and then multiply by 4, you can get total area. That's one way to do, right? There are also a quick way. I'm pretty sure Emma has another quick way to solve the problem. Okay. You can find the area of each right triangle. Now, my question could be, what is the area of each triangle? Okay.
Minus 100 by the area of the walkways.
Yeah, that's areas of walkways are very hard to find out. If I have to find the areas of walkway, how to do that? Now, Emma will do like that, right? 10 times 10 minus the area of the shaded region, because to find the shaded region is easy to find out, actually. If you're trying to find the areas of walkway, it's very difficult. It's not a regular shape. It's not a rectangle, right? Of course, later I'm going to ask you, how do you find the x, right? What is x? My first question is, second question, what is x? Now, some students find x first, okay? Then you find the area, okay? But if you find the area, then you can find the x quickly. Why? If the area is 64, I just assume area is 64, okay? Oh. You're right.
Oh yeah, it is 64.
Yeah, that's right. If you just like a puzzle, you shrink it, okay? You remove the space. You remove the space, remove the sidewalk, then you get the area. Okay, so this side would be 10 minus 2, which is 8. 8, 8, 8. So the area is going to be 8 squared, 64. Right? Whoa. And then once you get that, you can get x quickly. You know why? X is half of the diagonal, right? Right? So 2x is going to be 8 times square root of 2. So x is going to be 4 square root of 2. But if you can find the x first, are you still able to find the total area? Because x times x divided 2 and multiply 4. And you get 64 again. Okay. So it depends on which one is first. But if you know the area, right, that's the most quick way to get the length. That diagonal length is going to be the side length times square root of 2. Okay. Yeah. So this is yeah, if you know how to solve them, you have the knowledge to solve the problem. The question is whether you're able to solve it by yourself. Okay, so here's the next question. All right, so the next question is, this is a square, right? It's going to be 1, 1, 1. Right? Then and 2 square root 2. Yeah. What is the total area of this figure?
Plus 1. We got 1 plus square root of 3.
No. What? Any answers? Yeah. All you have to do is find this side A, right? But by the Pythagorean theory, A is going to be square root of 2 square root 2 square minus 1, which is 8 minus 1, which is square root of 7. That's it. So the total area
1 plus square root.
is 1 square plus half of 1 times A. So it's 1 plus square root of 7 divided by 2. Okay. Okay, let me talk about the special triangle. A triangle was, if this is 60 degrees, this is a 30 degree, right? Then the total sum of it. So this is right a triangle, but it's so special. We have to know that. So if this is a C, this is a A, that's a B. The relationship is A over C is going to be 1/2. B over C is going to be square root 3 over 2. Okay, this is special. Okay. Yeah, let's find out. Question. Here's a special triangle. And this is 30 degree. That's a 60 degree. Okay. And this side is a 1. And I'm drawing the line passing through here, and here's a rectangle. Okay. Yeah, this is a height. This is H. What is H? Any idea? How do you find H? Joshua? Yeah, that's right. So when you look at this triangle, there's a couple ways to do. One is just look at this one, right? Here's a 1. Here's 60 degrees. But then this must be 30 degrees. And this will be H. So H over 1 should be equal to square 3 over 2. So H is square 3 over 2. That's a quick way. Right? That's true, right? All right, let's look at the next one. Okay, B, A, C. This is Y. X. This is a 2, here's a 1. Okay. We're going to find the ratio, the triangle BXY over the area of the triangle ABC. Okay. So you have 2 triangles there, right? BXY and ABC. ABC is a large triangle. Yeah, so I also assume that this side is 3, okay? Make it easier. So AC equals BC equals 3. Okay, so this is the isosceles right triangle. So you know the area is ABC, right? So the area of triangle ABC is going to be 3 times 3 divided by 2. It's 9/2. So the question is, what is the triangle of BXY? Joshua? Hmm? Any ideas? Wait. Emma? Emma? I have to call somebody's name. Let me check. Who is that? Ellen. Catherine. Haven't heard from you for a long time. Catherine. Amy. Okay, Henry.
Kevin.
Yeah, Kevin always give me answer, right? Kevin said 2/9. Okay, let's try. Okay, look at this triangle, right? It's an isosceles triangle, so it's a 45 degree, 45 degree, and the 45 degree. So that means you have a triangle here, and the 45 degree, 45 degree, and this side is 2, here's A, right? Right, this is an isosceles right triangle. So the area of the triangle BXY is just equal to A squared divided by 2. Now what is A squared? Okay, A squared plus A squared equals 2 squared. So this implies A squared equals 2. Now when you put there, the area of the triangle BXY is just 2/2, which is 1. So the area of the small triangle is 1. Right? Then the ratio is 1/2/9, then it'll be 1/9/2, right? So the ratio is going to be 1/9/2. So it's 2/9. So Kevin did it right. Okay. So you calculate the area. Now, yeah, you calculate the area for each of each triangles. Okay, so let's look at the next one. This is a rectangle, and this rectangle, I'm going to draw another rectangle. Okay, so A, B, C, D, H, E, P, G. Okay, so I know there's angle here, BEP. Oh, this is going to be F, EFG. Okay, so this is going to be 30 degrees. It's a right triangle. Okay, right rectangle. Okay, this symbol. Okay, so I also know that this side is 12, and the FG is going to be 2 square. Yeah, let me check. I use a standard, okay? Okay, I'm not going to use it number 12. Let's assume that this is going to be 2. That's going to be 1. Make it easy. Okay. So I know the dimension of the interior rectangle. I want to find the dimensions of the larger rectangle, or the outer rectangle. All right. Can you do that? Right, so this is a rectangle, right? So we know the dimension of the rectangle, 2, length is 2, the width is 1. Okay. But I also know that one of the angles, here is 30 degrees, right? So from here, you can tell that BF is going to be 1. Got it? Because it's going to be half of it. It's a special triangle. Okay, what is FC? And this will be 60 degree, right? So then this will be 30 degree. This will be 60 degree. So at this corner, an FC is going to be square root 3/2, okay? Because it's 30 degree, okay? So then add them together, BC is going to be 1 plus square root 3/2. Okay? And this will be also 30 degree. So DG, right, is going to be 2 times square root 3/2, which is square root 3. How about GC? GC is just half of GF, so just 1/2. So this implies DC equals square root 3 plus 1/2. Okay? And what is the area? The area of the larger rectangle, ABCD, is just product of those two numbers, right? So it's going to be 1 plus square root 3/2 times square root 3 plus 1/2, right? Multiply them out, you can simplify it. So it's square root 3 plus 1/2 plus 3/2 plus square root 3/4. Okay. And then add them together, it's 2 plus 5/4 square root 3. Okay. So this is the area. Okay, my last question, maybe last question. Okay, here's a rectangle. Okay. The width is increased by certain percentage, okay? Increased by maybe by 50%. And the length is decreased by what percent so that the area of the rectangle remain unchanged. remains unchanged. Okay, so the width is doubled, right? Almost, right? Increased by, no, not double, by 50%. Width is increased. So the length must be shrunk a little bit. Otherwise, you're going to get large area, right? You want to make sure the rectangle does not change the area. Okay, yeah. So can we figure it out? You probably need to set up an equation. You can call it X percent. By what percent? So let's call it X percent. Okay, then you write down the equation for the X percent. Somebody claims decreased by 25%. Okay, let's draw the picture here. Again, it's decreased. W prime, L prime, right? Definitely it's increased by 50%. So it's going to be W plus 0.5 W. It's 1.5 W. Okay, right? And this will be decreased by X percent. X percent should be X divided by 100. Okay, so this is 1 minus X over 100. Okay, so the area remains unchanged. So here's the area is going to be LW. This side of the area is L prime and W prime. So which is going to be 1 minus X over 100 and then times 1.5 LW. Now remains unchanged means 1 minus of this should be equal to 1. Otherwise the area will be changed, right? Because this is the area of the original area, A. So there's a factor times A there, right? Then you solve the equation. Okay? So how do you solve the equation? Well, it's a 1.5 is 3 over, right? Use the fraction better. 3 over 2 equals 1. So 1 minus X over 100 equals 2 over 3. Then X over 100 equals 1 minus 2 over 3. It's 1/3. Then X equals 1/3 times 100. Okay? So it's going to be 33.333. I don't know how to get it 25%. Okay? 33.3% about. Okay? It's about 30.3 decreased by this. Okay? Yeah, you have to write down the equation. Don't by guess and try. Okay? You set up the equation, then, and Kevin, you did not even do computation. You just think about the decrease by 50%. Then you're not going to get this. Okay? Yeah, don't by guess and try. Okay? You have to do the computation.